Okay, so this is an exciting day, besides the 2-hour delay. We actually get to start our very first real 8th grade science unit. So far we've been doing all review. So you guys have been absolutely amazing in the review. I have very high hopes that once we actually are starting into our real science stuff, that a lot of this is also going to be familiar, and that you guys will keep up the good work. So we are going to start with a unit called non-contact forces. So first of all, what does the little prefix non mean? What does it stand for, Paul? No or not, right? What do you think, when you think about contact, what do you think of?
Football.
Okay, and why would football be considered a contact sport?
Because you hit each other.
Yeah, you have to. You don't just like run up and be like, boom, right? And just like come to an inch away from hitting them. Yeah, you actually have to tackle them, touch them, right? Poor Isaac definitely had some contact with his sunflower on his dirt bike, right? So, yeah, again, that's a first. So if we say no contact, what are some sports that would be no contact, or activities that would be no contact or non-contact? What would we consider those, Corbin?
Tennis.
Yeah, like you're not trying, like there's contact between the ball and the racket, but you're not like coming in contact with the opponent. Okay, what else? Yeah, you're not really supposed to. Again, there's contact between the ball and the bat, the glove and the bat, or the glove and the ball, right? But you're not allowed to like just give a stiff forearm and like take out the first baseman so that you're safe on first, right? That's not okay. What else?
Basketball?
Yeah, and there is some physical contact, but yeah, depends on how Mrs. Johnson plays basketball now. It's not supposed to, which is why there's fouls, right? Like you can't have too much contact. Like a little is okay, but that's not the point of the game, is to like knock people down and like elbow them and give them a fist to the face, right? That's not okay. What about like swimming, right? Track and field, right? All of those you would consider like non-contact activities. Hopefully like marching band is even like a non-contact. Like as they're marching, you hope that there isn't a collision. I've seen some accidents where like lines get crossed and like people go falling, flying everywhere. But the intent is not to have that contact, right? So you have a good idea about contact and non-contact. So now let's kind of apply this to forces. Can forces act on each other if there's no touch? Can a force cause something to move if there isn't a touch involved?
No.
No. Okay, who says yes? Max? What do you think?
If you're like going fast enough to like make something over, you can put it.
Okay. I like the idea that you're talking about something with movement, for sure. What do you think, Paul?
Magnets.
Oh, all right. So,
Same force, like positive and negative side, to positive and to the negative side, like contact each other, they would just push each other away.
okay. So they could either push each other away, or can sometimes magnets pull things together, come together? Sure, that's a really good one, for sure. Magnetic forces can do that, right? They almost work invisibly. Any others? Why are we not floating around in the room right now, which would be way cool? Maybe annoying at some point, but it'd be cool for the moment. What do you think back there, Ford? Gravity, right? There's no hand pushing us, or there's no tether holding us to the ground, right? That no physical thing that we can see, but we're all being held here, right? So that force of gravity. Those are the two that sometimes we do come up with. There's actually a third that's going to be involved in this unit, but it's the electrical fields that a lot of times people don't, consider as a non-contact force. But it is a force, and we're going to talk about it. Kind of works the same way that Paul just described with the magnets. With the positive and a negative, they might attract or they might repel.
Air Force? Like, for example.
Oh, like air pressure?
Yeah.
Okay, that's a really good thought. The thing is that even though we can't see the air most of the time, it's so small, it does actually have mass to it. And if it has mass to it, then it is a contact. And if you have enough of those tiny little air molecules, it's putting that pressure that you feel like as you wave your hand through the air, or like, you feel that air pressure depending on like how, like what situation you're in, right? But that's a really good thought, right? That's actually a physical, I know, but it was the air, it was actually something solid that little particles. So lots of little particles, but yeah, it's a good thought, really good. So we have our electrical that are gonna kind of act along like what we said with the positive and negative, like Paul said with magnets. Magnetic fields, which have poles that we call north and south, but they also react like a positive and a negative. So the same kind of thing that we'll talk about with electrical. And then finally, our gravitational fields. Notice with all three of these, we're calling these fields. Do we mean like a cornfield, a hay field? No, we're not talking like a farming country field like we're used to. A field we'll talk about is a region or an area. A lot of times we're going to be showing these with arrows. Okay, so these arrows are going to show kind of the direction that the forces are moving within that field. So we'll pay really close attention to arrows this unit. Okay, so we call these areas fields, and it's called a field model. And it can be used to explain how objects exert forces without touching, okay, without the touch. Has anybody seen The Hunger Games? Oh, it's getting fewer and fewer every year.
I've heard about it.
Okay, you guys need to read the books and you need to watch the movies. They are too good not to watch. I know they're getting a little older now, but you guys have to watch them. You'll love them.
Where can I watch the movies?
Okay, so in the second one, and Henry, maybe you remember this, like in the second one, they're in the arena fighting, and it's like a kind of like a make-believe world that they're in, and there's an electrical force field that's around to keep the players in the arena. And when they get to the end of it, like they find like a glitch, and like they actually are like trying to, like they're realizing they've made it to the edge of the arena. And so this is what I'm always picturing, and we'll watch a clip of this. We probably won't have time today, but we'll watch it tomorrow. Like when they go up, and like it's this invisible force field that is keeping them in. And so that's what I'm always picturing in my mind whenever we're talking about these fields, kind of this invisible area that these forces are working in. And so an object is thought to have a region of influence that we call a field. Right? So region of influence sounds like fancy, but it's not. It's just like this area around an object. And when you put a second object that has an appropriate property in that region, so if it's close enough to that first object, then the field is going to exert a force on it that can cause some changes in the second object. So you need a total of two objects, and they have to have the appropriate property. And you're like, well, what the heck's an appropriate property? Well, each one of these electrical fields has a different appropriate property, and we'll talk about what those are as we get to each type. Okay, so this is all going to happen kind of like through the voodoo way, no touching, right? It's just going to magically make things move. And so that's why it always seems kind of like mysterious. It's like, you're not touching it. Like, obviously, if I put my hand on this, I can make this move. But if I'm just like, try to get it to move, like I can't do it. Now, kind of like Ronan did, like if you blow on it, well, that's still a contact as those air molecules hit the book like that he tipped over, or if I would blow hard enough, I could get the papers or, my towel up here to move. But that's still a contact because it's those air molecules touching that, making it move. So the first one we're going to look at is electrical fields. And electrical fields exist around objects with an electric charge. And so the appropriate property for electrical fields is charge. Now, This is something that people have a really hard time with, is charge. It's not like charging up your cell phone. It's not like having a full battery. Like, that's not what we're talking about. When we're talking about charge, it is having an unequal number of protons and electrons. Do you guys remember those words? From 6th grade, maybe? You probably had a big unit on it with Mrs. Radel. Even in 5th grade, I know that you had this as well. So 5th and 6th grade, you guys covered protons, electrons, neutrons, the parts of an atom. You dealt with charges. So this is not new information. And next year in physical science, you're going to have it's a huge part. Like, actually, we're still doing it right now. Like, we're going to, for the first 3 units, it's going to be a big part of what we talk about. So the better you can get like an understanding of this year and like really feel confident, next year just makes it easier to start the year. So appropriate property is charge. All that means is if you have 5 protons, you have to have anything but 5 electrons. You can have 4 electrons, 3, 2, but it can't be balanced. You could have 6, 7, 8, but it can't be 5. So anything where they don't equal the same number. Because if you have 5 protons and 5 electrons, we call that neutral. They're balanced. They cancel each other out. So for every positive, there's a negative, and they cancel each other. So if you have just one off of that, then you have something that's charged. And this idea of charge, it's really simple, but people get like, I don't know if they want to make it fancier or more confusing, but it's very, very simple. So if you have 2 objects that have an unequal charge to them, like one's positive and one's negative, that's the appropriate property. And when that happens, they can exert forces on each other. Forces like attraction and repulsion. So they can, show me with your hands what you think attract means. What about repel? Good. So attract, repel. Right? And it all depends on the charges. If they're positive and positive, negative and negative, positive and negative, like that's going to determine are they going to attract or repel. And electric forces get weaker as the distance increases. So the farther away from each other they get, the less influence they're going to have. And that's pretty logical, I think. Pretty common sense. Did I go too fast on that? All right, so to understand these fields, we need some basic background to help us as we put all this together with the atom. So, kind of already said it, what are those 3 subatomic parts of the atom, or those 3 things that make up the atom?
Protons, neutrons, and electrons.
Very good. And we hadn't even said the word neutrons, so you came up with that one. Very good. Or, you're smart enough, a lot of times the answers are in front of you, right? So that's always good. If you're not sure, kind of look around. My physical science, I've had these things up here, which you guys have probably noticed, and we were doing a Kahoot, and like 6 of the answers are on the board right there. And I was like, well, maybe you might want to look at the board. And then like after a while, like I'd see people's heads like flip over to that side because they're like, maybe the answer is, still up there. So always able to use things that are right there in front of you for answers. But I think, Paul, you just came right up with it on your own. Very good. So we have the 3 parts, right? And so the protons, what charge goes with protons? Paul, the only one that remembers the atom. Andrew? Positive protons, right? What charge goes with the electrons? Max? It's the opposite of positive.
Negative.
There we go. All right, and then what about the neutrons? Atlee?
No charge.
No charge or neutral. Very good. Sometimes people remember this as PEN, P-E-N, protons, electrons, neutrons. But really, I think at this point, most people already feel very confident with this stuff. So all objects naturally have an equal number of protons and electrons. The charge comes when they don't have an equal number. So maybe you have more protons or maybe you have more electrons, but that makes it charged. That makes it uneven and we call that item charged. Again, not full battery life, nothing like that. We're talking protons and electron numbers. All right, so here's an example so you can kind of visually see. What do we call this central portion? Anybody remember? Where the protons and the neutrons are? It also starts with an N. Henry? Nucleus, very good. So the nucleus is where we have the protons with the plus sign and then the neutrons. So what charge does the nucleus have based on this picture? And if we're telling you that the protons are in the nucleus, what charge does the nucleus actually have? It's positive, yeah, because that's where the protons are. And then around the nucleus, we have the electrons, which you told us were negative, right? Max said those are negatives. So anybody remember what a positive and a negative want to do? Do they want to attract or do they want to repel? Paul?
Attract.
They do want to attract. So these electrons are kind of being held invisibly through that attraction. Okay? And so the negatively charged electrons orbit around that positive nucleus. And the positively charged nucleus holds the negatively charged electrons in something that we call an electric field. Those two areas are not touching. It's just that invisible attraction between the two. So we have an electric field at work in every single atom that we have. But the entire carbon atom itself is actually neutral because we have 6 total protons and we have 6 electrons. So if we have 6 and 6, that balances, meaning that it's neutral. Okay, we'll stop there.